there, grade 11s, and welcome to this week's Physical Sciences. What we're going to be doing is revising some of the topics that we've covered in the lessons over the last few weeks. So what I've put together for you are a few multiple choice questions and then one or two long questions just to help you get the content in your head in terms of how is it asked, what are the things to look for when we are answering these questions. Remember, at all times, your teachers are there to give you a hand. If you're not sure of something, ask them. If you're not sure why I've given a particular answer, ask them. Okay, so this is just an extra thing for you guys to have a look at and to practice, but always remember, go and ask your teachers first. All right, so if everybody's ready, let's get going. We're going to start with Newton's laws and the revision of Newton's laws. So I've got, like I said, a few multiple choice questions. I'll read it for you, and then I'm going to leave you with some time to answer it. So the graph shows the relationship between the acceleration A and the force F required to produce that acceleration. I think there's a word missing here. Produce the relationship. Let me just add in the word here. Let's choose a better color. The relationship between the acceleration and force with mass being on a smooth surface. Okay, so it's required to produce the relationship between acceleration and force with the mass being on a smooth horizontal surface. Obviously, the gremlin was thinking much better than I was when I typed this question. So let's have a look at the options. So this is to show the relationship. Let's put it here. I'm looking for the relationship between force and acceleration. Okay, that's what I'm looking for. Your question is this part here. It says the gradient of the graph represents what? A, mass, B, displacement, C, average velocity, and D, final velocity. I'm going to give you a minute. You can chat to your friends, you can ask your teacher, you can work it out for yourself. I want you to choose the correct answer for this question. So I've got a minute starting now. Right, everyone, time's up. Let's have a look at what your answer is. So the options are A, mass, B, displacement, C, average velocity, and D, final velocity. The answer should be A, the reason being Newton's second law. So your F net or F resultant is equal to mass times acceleration. If you are comparing your force and your acceleration, so we're comparing those two, which is what we've got on the axes, then this must be my constant. And in a graph like this, your constant is represented by the gradient. So our gradient in this case is going to be our mass. Okay, moving on. The total mass of a parachutist and his parachute is 120 kilograms. The parachutist moves downward with a constant speed of 5.6 meters per second. The resultant force acting on the parachutist and his parachute is A, 0 newtons, B, 67.2 newtons, C, 120 newtons, or D, 1,176 newtons. Okay, again, I'm going to give you a minute to work through this, figure it out, and answer it. You've got a minute starting now. Okay, everybody, hopefully you have an answer. The answer that I'm going to give you or choose is going to be A. Now, there could be a whole lot of people going, but why is it A and it should be D? Because you've got to take the mass multiplied by gravity. What I want you to do is I want you to have a look at the way that this question is worded. Okay, so follow with me on the board. It tells us that the parachutist moves downward. So we have a direction, okay? It's got a constant speed and 5.6 meters per second. So let's just quickly make a note of a few things. Number one, speed is actually scalar. So you should be saying, but we need to be talking about a vector here. This is where the wording of a question comes in. We are given a direction because he tells us that it's moving downward, and we're given an information that this is constant. When you have constant, that means that you have a zero net force. Okay, so I just want to point out to you that you need to be careful because this word speed can throw you off a little bit. But what has happened is that there has been an extra clue put into the question because we've got the direction. So if you read the two of them together, speed being the number, okay, remember scalar is a number only. I can't write a number. Scalar is a number only. So I've been given the number and I've been given the direction. And together they should give you velocity. And if there is a zero velocity, or if there's a constant velocity, should I say, there should be a zero net force. Okay, if you're not sure of that, again, please make sure that you chat to your teachers so you can get that sorted out. Next question. I love watching these people or watching this sort of thing on TV when people try and show how Newton's laws work. So this is a tablecloth is jerked horizontally. A plate on the tablecloth, so let's put a comma there. A plate on the tablecloth remains in position. This is an excellent demonstration of A, Newton's third law of motion, B, inertia, C, Newton's second law of motion, or D, conservation of energy. So if you're not sure what I mean, I think a whole lot of you, or most of you, should have seen somewhere on TV a comedian or someone who's trying to do something funny. You've got this beautiful table and it's got plates and it's got glasses and knives and forks, and the person comes along and they pull quickly. And some people manage to pull the tablecloth out and all the plates and knives and forks and glasses stay there, and other people pull it and then all the plates and knives and forks come off and they crash onto the ground. That's what we're talking about. But we're talking about the example where you pull the tablecloth and everything stays there, just the tablecloth comes out. Okay, so you've got 4 options. Again, I'm going to give you a minute to figure out what the answer is. minutes starting now. Okay, so let's see what your answers are. Did you choose Newton's third law of motion? Did you choose inertia, Newton's second law of motion, or conservation of energy? The answer is B. It is inertia. Inertia is also known as Newton's first law. And why is this the answer? The reason is, with Newton's first law, Newton said that an object's going to continue doing what it's doing. So it's going to stay at rest, or it's going to stay at a constant velocity unless an external force acts on it. So if you pull that cloth quickly enough, the objects are not going to be dragged by the cloth. They're actually just going to have the cloth move out from under them, and they're going to stay doing what they were doing, which is sitting on the table. If you don't pull it at the right speed, you're then going to pull the object off the table with you. And remember that inertia is the resistance to movement. It's an object's resistance to movement. So the plate doesn't want to move, so it wants to resist movement, so it's going to stay there. And inertia and Newton's first law tie in together. They go hand in hand. Right. Hopefully everybody's with me so far. So that is what I've given you. A few questions for multiple choice. Now I want to get on to application of Newton's second. Oh, in fact, before I do Newton's second law, I've got one more for you. I forgot. Nearly forgot. I'm sorry. If I can get this to move. Newton's law of universal gravitation. I forgot about that. So one more question for you, and then we'll go on to Newton 2. Magnitude of the gravitational force between two mass pieces is F. If the distance between the center points of the mass pieces is, and now we don't know what's happened to it, the magnitude of the force between them will be 4F. So what happens to the center points of the mass pieces? Are they reduced by a quarter? Are they halved? Are they doubled? Or are they increased 4 times? And what I'm going to do is I'm going to give you this just to help you to answer that question. Okay, again, you've got 1 minute. Answer the question starting now. Okay, now I know this one can cause your brains to get in a knot. So what I'm going to do, because we've got to go for an ad break soon, is I'm going to show you that the answer is halved. And I'm just going to put into the equation, I'm going to use proportion, mass 1, mass 2. And what will happen is that should be a half squared. And because this value is at the bottom, this one here is at the bottom of the fraction, what will happen is that it will eventually invert. Remember, to invert is to turn over, and it will become 4, and that's why it becomes 4f. Okay, time for a break. You've worked really nicely up to this point, so we're going to go for an ad break, and then we'll come back and do Newton's second law. I'll see you soon. Hi there, everybody. Welcome back after the ad break. We're going to continue with some revision from what we've been doing this term. We did a few multiple choice questions before we went to the ad break, and I said to you we're going to do Newton's second law. Now, in the question or in the lesson that we had earlier on about Newton's laws, we started a question where there were multiple objects. So there were 2 carriages and a little train, and we didn't get to finish it. So what I want to do today is we're going to do something similar, and hopefully we're going to finish the question. So I've got the question for you. I'm going to give you some time to work it out, and then I will go through it with you step by step. Okay, so let's have a look at the board and look what I've got for you. A train consists of an engine and 3 carriages. Each carriage has a mass of 15,000 kilograms, and each carriage experiences a constant frictional force of 1,000 newtons. When moving along a straight horizontal track, the engine exerts a constant force of 30,000 newtons on the front carriage. And then it asks us to calculate. And let's have a look firstly at the diagram. So we've got the 3 carriages. So we've got carriage 1, we've got carriage 2, we've got carriage 3. We don't have a picture of the engine, but I'm going to say that the engine is over here. Okay. And then each one is going to have friction. I'll write the word out here fully, but I'm just going to write a small f there and a small f there. So it tells us each carriage has got friction. And then it asks us for these 3 questions. Calculate the acceleration of the train, then calculate the tension in the link A, and then calculate the tension in the link B. Okay, so I'm going to leave this for you. What I want you to do is just answer question A. So I'm going to leave it so that you can see the info at the top, and you can see that it says to calculate the acceleration of the train. And I'm going to give you, because this one's going to take a while, I'm going to give you 3 minutes to calculate the acceleration of the train. Okay, now just remember, you cannot or you should not add all the masses together and then treat it as a single system. You need to individually calculate. You need to use your 3 different systems. So last time I spoke to you about this, we spoke about drawing force diagrams or draw a free body diagram. So my hint to you to solve this is do a free body diagram for each little carriage, and then you solve or you answer the question from there. So I'm going to give you 3 minutes to answer or to calculate the acceleration, and we're going to start the 3 minutes now. Okay, everybody, your 3 minutes is up. And even if you're not finished, don't worry about it. Most important thing is that I want you to make sure that you've got the right idea, that you know how to solve or how to attack this problem properly. So just focus on what we're doing. Remember, if you're not sure, ask. Ask your buddy, ask your teacher, ask the person in the class who gets 100% for everything. Always a good idea to ask. You might be really, really confident, but there's just one thing you're not sure of, ask. Okay, there's nothing wrong with asking. It's a really good skill to have. So let's tackle this question. If I can get the board to listen to me, there we go. So let's go. I'm going to put the info on my screen again. So I'm going to have the engine over here. And it says that there's a constant force of 30,000 newtons. Okay? We're going to have friction going that way, and it told us that there's a frictional force of 1,000 newtons. But what I want to check here, each carriage experiences 1,000 newtons. Okay? So it's not 1,000 divided by 3. Each one of them is going to experience 1,000 newtons of friction. And remember that friction will go in the opposite direction to which the engine is moving. So if the engine is moving to the right, friction is going to be acting to the left. It then tells us that the mass is 15,000 kilograms for each one. So I'm just going to make a note of that. Okay, kilograms. All right, so I've got my info. Now I can work with some space. And I said to you, the first thing to do is to draw a free body diagram or a force diagram. So let's start with, I'm going to give these numbers. I'm going to make that number 1. I'm going to make that one number 2. And I'll make that one number 3. I'm going to start with number 3. And make sure that I've got some space because I think we're going to be doing a lot of writing here. Number 3. So here's my block. Number 3. What are the forces that act on it? I've got tension B acting in one direction, and I've got a force of friction of 1,000 newtons acting in the opposite direction. Then for block number 2, I've got tension A to the right, and I've got B to the left, and I've got friction to the left. Okay? And for the first one, for block number 1, I've got my applied force. So I'm going to say force applied. I've got A acting in the opposite direction, and I've got my 1,000 newtons of friction. Okay, so those are my 3 diagrams. Now, what do I do with the 3 diagrams? I need to translate these into equations. So for number 3, I'm going to say that B minus my friction equals MA. Now the question is, how did I work that out? Or where did I get that from? Remember, we're doing Newton's second law here. So we're using F net equals MA. And how do you calculate your net force? You need to make sure that you take into account all the other forces. So all the forces that are acting, what do they result in? They end up in a net force. So that's how we get that one. So if I want to make B the subject of the formula here, I'm going to say B is equal to MA plus 1,000. And I'm going to make this equation, I'm actually going to make it equation number 3 because it goes with block number 3. Right, let's have a look at the second one. What have I got going on with the second one? Okay, I'm going to put number 2 over here. I've got A minus B, and I'm going to go minus 1,000 equals MA. Again, we're using Newton's second law. and I want to make A the subject of the formula. So I'm going to end up with MA plus B plus 1000. And I want to make this one equation number 2. Give myself some more space here, not too far, so I want to see the pictures. Then for the first block, so for block number 1, I'm going to have force applied minus A minus 1000 equals MA. And then from there, I'm going to make force applied the subject of my formula. So I'm going to end up with MA plus A plus 1000. And I'm going to make this my first equation. So what I've got here are 3 equations. This means we are going to be working with simultaneous equations. Okay, and a lot of people go, oh my goodness, I don't know what to do with simultaneous equations. That's not a problem. We're going to work through it. So for number 3, we've got B is equal to MA plus 1000. For 2, we've got A is equal to MA plus B plus 1000. And for the first one, force applied equals MA plus A plus 1000. Let's just look at our pictures again. Where did I get this from? I've got B acting in the direction to the right. I've got 1000 acting to the left. And I used Newton's second law, F net equals MA. So that is where I'm getting all of these equations from. I'm just using the information that I've been given. Now, let's look at what we've actually been asked to do. We've been asked to calculate the acceleration of the train. And we have to use our 3 equations here. Okay? So each one of them has got A in it. But we are going to need to try and solve for A. So let's just start with number 3. I'm going to do a few substitutions into number 3. So B equals MA plus 1000. So this is number 3. B equals M times A plus 1000. And we know that the mass is 15,000. So what we've got here is 15,000 A plus 1000. That's actually what my third equation is. And I can do that for all of them. So let's just do it quickly. So for number 2, I'm going to write here that A is equal to 15,000 A plus B plus 1000. Okay, now if you've been following, hopefully you can now see that we have got a situation where we can probably solve for A or B at least, or even the acceleration using equation number 3 and equation number 2. Okay, but I know that we're also approaching an ad break. So what I'm going to do is I'm going to leave these equations like this. We're going to come back to it. You are going to have a bit of a break. You're going to stretch, do what you need to do. And after we come back from the ad break, we're going to carry on with solving this question, solving this calculation. So I'll see you shortly. Welcome back from the ad break, everybody. Hopefully you are still able to focus and you can remember what we did before the ad break. We were speaking about calculating the acceleration for the system. So let's just have a quick look. We had the engine, we had drawn the pictures for it, and then we had started putting together our simultaneous equations. Okay, so while you were on a break, I wrote down here that I want to substitute 2 into 3. So I want to combine equation 2 and equation 3. So equation 2 has got A being equal to, let's just have a look here, MA plus B plus 1000. A is equal to MA plus B plus 1,000. Okay, so we're going to say A is equal to 15,000 A, and we're going to then add in B, which over here is going to be 15,000 A plus 1,000. 1,000 A plus 1,000. And then we're going to add in 1,000 over here. So we're going to end up with 30,000 A from the looks of things, because I'm going to add those two, plus 2,000. Which is fine, but we still don't know what our acceleration is. So now the next step is we are going to substitute 1 into 2. So here we go. We're going to substitute 1 into 2. And as I get closer to the answer, I get more excited, and my handwriting is now terrible. Hopefully you can still read it. I'm looking for this equation here. My force applied equals mass times acceleration. So let's have a look. So force applied equals MA, which is 15,000 A, plus A, and I'm going to put A in straight away, which is 30,000 A plus 2,000, and then I'm adding 1,000 at the end, even though everything's squished together. Let's just make sure MA plus A plus 1,000. Phew, this is getting quite long. So this value here is 30,000 equals and this I'm missing a 0 because there should be a 30,000 there. 45,000 A plus 3,000. Okay, so 45,000 A is equal to 30,000 minus 3,000. And then we're going to have a little equation here, or should I say a little fraction. Let's give myself a little bit more space. Okay, we're now going to say 30,000 minus 3,000 is 27,000 divided by 45,000. And our acceleration, and now this is where we need to see if we can find, I need to see if I can find my calculator somewhere. There we go. Come on, calculator. I'm going to go 27,000 divided by 45,000 is going to give me 3 over 5, and that gives me 0,6. So here, my acceleration is 0,6 meter per second per second. Whew, that was a lot of working out. But remember, we had 3 separate objects, and we needed to, even though you think, oh, there must be a shortcut, and there probably is, it's not really great physics to do it the other way. So with this one, we've got the 3 individuals. What have we done? We've done the force diagrams, or the free body diagrams. In this case, I did a force diagram for each one of them. We indicated all the forces. We used simultaneous equations. And from there, we did the proper physics and the proper mathematics, and we got to our answer of 0,6. Okay, well, that's only one question. So let's have a look at the next 2. And now I'm not going to worry about letting you do it. We'll work through it together. We now need to calculate the tension in link A. And if you remember, what we wrote down was that A is equal to mass times acceleration, so 15,000 A plus B plus 1,000. That's what it was originally. But if you look back down here, we ended up with A being 30,000 A plus 2,000. So that is what I am going to work with here. We're going to say, I'm not going to substitute in B. I'm just going to go straight to A is equal to 30,000. And my acceleration is 0,6 plus 2,000. So now again, I need to find my calculator, and I'm going to go, let's just move the calculator over here. I'm going to go 30,000, yep, that's the right number of zeros, times 0.6, 0.6 equals 18,000. And I need to add 2,000, and that's going to give me an answer of 20,000. So my A is equal to 20,000 newtons. And then, to do the last little bit, the tension in link B. So if you can remember, it was B is equal to mass times acceleration plus 1,000. So B is equal to 15,000 times 0,6 plus 1,000. So B is equal to, and we're going to find our calculator again. Let's clear it. We're going to say 15,000 multiplied by 0.6 gives us 9,000. We add 1,000 and we end up with 10,000. So our answer for B is 10,000 newtons. Okay. Hopefully you kept track of what was going on. Does look like a long and intense and involved type of question, but if you break it down into your individual components, you do the diagram for each one, and then you use the simultaneous equation, you just plug them in one after the other. Looks complicated, but it actually is really simple. It breaks down into nice physics, nice mathematics, and you can put in all the information that you have and you solve from there. And even if it ends up that something goes wrong, you get nervous, your calculator doesn't give you the right answer, you put the wrong number in, whoever is marking can see your thought process, can see your steps, can see that you understand the physics. And that way you can get marks for thinking and for the physics and not just for the fact that you tripped on your calculator. So don't give up hope and do all of these steps so that you can get as far as you can, even if the final answer something's not 100% correct. Okay, so well done for tracking with the Newton's laws, guys and girls. But to end off with, what we're going to do is we're going to do a few questions on intermolecular forces and shapes of molecules. Okay, it's an important section. Just want to make sure that it's fresh in your mind before you head off to holidays. So let's have a look at what I've got for you. Okay. Again, a multiple choice, and I'm going to give you some time to answer it. A CH4 molecule is nonpolar because A, the 4 hydrogen atoms are arranged symmetrically around the carbon atom. B, an even number of hydrogen atoms combine with the carbon atom. C, all the valence electrons of carbon are used. Or D, the difference in electronegativity of carbon and hydrogen is small. Okay, so I'm going to give you 1 minute to work that out. If you need to, have a look at a periodic table, look at electronegativities. 1 minute starting now. Okay, everybody, hopefully you've had a chance to answer the question. My answer for this question is A. The 4 hydrogen atoms are arranged symmetrically around the carbon atom. Before we move on to the next question, I just want to check something with you, check your understanding. Because a molecule has a polar bond doesn't always mean that it is a polar molecule. Okay, so you need to get those two concepts separate in your head. A polar bond has to do with electronegativity and the difference in electronegativity. So if there is a large electronegativity difference, the shared electrons are going to spend more time with one atom than with another, and so your bond is going to be what we call polar. That will then cause a polarity, so in other words, a slight positive or a slight negative between two atoms. But if you have a case of multiple situations like that, like we do with CH4, there's a polar bond, but there's 4 of them. So they're arranged around, the hydrogens are arranged around the carbon. It's now symmetry. You're not going to have one side is distinctly negative and one side is distinctly positive. So you need to make sure that you remember that a polar bond does not always mean a polar molecule. However, you cannot have a polar molecule if you have a non-polar bond. Okay, so they don't work exactly opposite to each other. You just need to remember polar bond. It can be a polar molecule or a non-polar molecule. It depends on how the atoms are arranged. But a non-polar bond, you're definitely going to have a non-polar molecule. Okay, let's move on. Let's test your brains a little bit more. See what we've got here for you. So, the intermolecular forces between ammonia molecules in the liquid phase can best be classified as A. Iron dipole forces, B. Van der Waals forces, C. Hydrogen bonds, or D. London forces. Now, I'm not going to give you a minute to work this out because you should be able to tell me straight away what it is. There are 3 substances, or should I say there are 3 specific atoms that will give you hydrogen bonds. And they must obviously be bonded to hydrogen, but they must be our 3 small atoms that are highly electronegative. So nitrogen, oxygen, and fluorine. So if you get NH3, H2O, or HF, you should expect hydrogen bonding every time. So in this case, you should be able to say to me, ma'am, the answer is hydrogen bonding. Obviously, because it's got nitrogen and hydrogen, you'd be correct. So intermolecular forces between ammonia molecules in a liquid phase can best be classified as hydrogen bonds. Okay, good. Let's have a look what else I've got for you. Boiling point of HF is 20 degrees. Remember, I've just said to you there were 3 substances, NH3, H2O, and HF, okay, that have hydrogen bonding. So the boiling point of HF is 20 degrees Celsius, and that of HCl is minus 85 degrees Celsius respectively. Okay, why have I got these 2? They are in the same group. Okay, so they are halides. So it's a hydrogen with a halogen. They're hydrogen halides. HF is a higher boiling point because, and again, okay, hydrogen bonding, so let's think it through together. It has a greater molecular mass, okay, possibly, all right, but we know that there's something special about HF, so let's say no for A. It is a stronger acid. No, we're not worried about acids because acids have got nothing to do with boiling points. C, there are no intermolecular forces between the HF molecules. No, there are always intermolecular forces, so it can't be C. And then D, the intermolecular forces between the HF molecules are stronger than the intermolecular forces between the HCl molecules. I'm going to go with D, and the forces there would be hydrogen bonds. Right, let's have a look at this. Last little bit before I let you go. A pupil boils a sample of water in an open beaker in the school laboratory. Pupil finds that the boiling point is 98 degrees Celsius. On another day, the same pupil carries out another similar experiment on another sample of water at the same place. This time, the pupil finds that the boiling point of the water is 100 degrees Celsius. So what we have to do is define the boiling point of a liquid, give two possible reasons for the two different boiling points, and then the intermolecular forces between water molecules. So let's see what we can answer here. What is the boiling point of a liquid? Right, it is the temperature at which a liquid becomes a gas and a gas becomes a liquid. Okay, so it can be both. Gas becomes a liquid. So where it becomes a gas or where it goes from a gas to a liquid. That's our boiling point. Remember that boiling points are different for different substances. Okay, and unfortunately, guys and girls, I thought we might be able to get to B and C, but it looks like we're running out of time. So what I'm going to say to you is just keep going. Well done for working so nicely today. Remember to just keep your science in your head, even when you go on holiday or the weekends, a little bit of work every day. If you're not sure of things, ask your teachers, ask your buddies, ask somebody who's done this already. Most important thing is keep trying, keep working at it. We will see you soon.